Find the length of the longest increasing subsequence using dynamic programming. Problem statement: the input is an array and the output is the length of the longest increasing subsequence. So example 1. The input would be this array, 5, 8, 7, 1, 9. The output would be 3. 5, 8, 9 is the longest increasing subsequence. Note that the increasing numbers do not have to be adjacent. So this is the code. We have a function called length of the longest increasing subsequence where we pass an a, or the array. Then we make a dynamic programming table that's filled with ones. Each number has at least a subsequent length of 1. That is why everything starts at ones. So we have a for loop that goes through all the numbers from the second number in the array to the last one. Every time the I value changes, the j value will be 0. This will help you go through every number before the I number, which will help you find one that's smaller than it. So this will make sure that j is smaller than I, and it will go through each one. Here you check to see if it is smaller. And since 8 is bigger than 5, it's an increasing sequence. Up to 5, the longest increasing subsequence length is 1. And up to 8, the longest increasing subsequence length is 1. So 8's new longest increasing subsequence length is 5's longest increasing subsequence length plus 1, which is 1 plus 1, which is 2. You increment j, and since j is I is equal to I, you get out of the while loop. And now I is pointing at 7 and j is pointing at 5. Since 7 is bigger than 5, it's an increasing subsequence. Up to 5, the longest increasing subsequence length is 1, and up to 7, the longest increasing subsequent length is 1. So 7's longest increasing subsequence length is now 2. And since j is now pointing at 8, and 8 is smaller than 7, and since 8 is bigger than 7, it's not an increasing subsequence, so it doesn't do anything. Then it will increment j again, and it goes out of the while loop. And since 1 is, so now I is pointing at 1, and j is pointing at 5. Since 1 is smaller than 5, it's not an increasing subsequence, so then you just increment j. Same thing when it's pointing at 8, and when it's pointing at 7. And now that they're equal, you go out of the while loop. And now I is pointing at 9 and j is pointing at 5. Since 5 is smaller than 9, it is an increasing subsequence. So up to 5, the longest increasing subsequence length is 1. And up to 9, the longest increasing subsequence length is 1. So now 9's longest increasing subsequence length is 2. And now j is pointing at 8. Since 8 is also smaller than 9, it's an increasing subsequence. Up to 8, the longest increasing subsequence is 2. And same with 9. So now 9's longest increasing subsequence is 3. And since now 7 is smaller than 9, but so up to 7, the longest increasing subsequence is 2. And up to 9, the longest increasing subsequence is 3. Since 2 is smaller than 3, even though we did add 1 to the 2, it will not be higher than 3. So we do not update the dynamic programming value for the longest increasing subsequence of 9. So it stays at 3. Same when it's pointing at 1. And now that they're equal, and now I and j are equal since you incremented j. So then you go out of the while loop. Since I points to the end of the array, it goes out of the for loop. Then you return the last dynamic programming table value, which is 3. So the output would be 3. Thank you for watching.